Halisi Ayala. Welcome to part 2 of my video series presenting the takeout ordering app which I developed in a full stack developer course. In this video, I'll present the inner workings of the database and the API used in my app called OrderIn. The OrderIn app uses a Strapi database to store the data in the backend. The Strapi database is supported by a PostgreSQL database. Let's take a look at Render, where I deployed the backend of the app. You can see the Postgre database here called Menus. And then the Strapi web service is called Order here. Here is the public link to my Strapi database. I can access the admin dashboard by entering this public URL /admin, and that gives me a view into my database here. I can enter and update content through the Strapi interface, as well as configure access privileges to the content in Strapi's settings. Strapi's content is organized in collection types, which I defined in development to include fields and links to one another. We have a content database for users. Every time someone logs in, the app creates a new record in the user content type. The app can also compare username password credentials against the user content type stored in order to authenticate someone at login. The restaurant content type is key as it defines the restaurants people can order food from. It includes a link to an image uploaded to Strapi for each restaurant. You can also see that it is linked to certain records in the dish content type defined here. Every dish is associated with a link to a restaurant. This link allows a menu to be displayed for each restaurant. Finally, we have the order content type, which stores the food orders that people place. When a person completes the checkout process, a GraphQL mutation is triggered, creating a new order record. In the code, the backend folder is where I stored my Strapi installation. You can see that from the JSON package that Strapi is using GraphQL as well as a Postgres database and Stripe. I liked working with Strapi because it offered a very friendly visual interface into the data and the config. However, I found Strapi to be challenging and quirky in its deployment. Now let's talk about the app's API endpoints. When a developer creates a new content type in Strapi, Strapi creates an API endpoint for that content type. For example, if I access my deployed databases URL and I add API/restaurants, you'll see a visual interface into GraphQL. You'll actually see the restaurant object. These are all of the restaurants stored in the database, as well as data about them, including the restaurant's name, the restaurant's description, and information about when the restaurant record was created, updated, published, every piece of the information having to do with the restaurant. Similarly, if we were to access the Strapi URL /API/dishes, we would see all of the data pertaining to dishes stored in the database, such as, again, a name, a description, even a price in this case, as well as information about which restaurant this dish is associated with. Strapi also makes use of the GraphQL API, which offers a visual interface to testing out queries and their results. For example, let's hit my deployed database URL /GraphQL. If I enter a query and I click this button, I'll see the data response to this particular query. Notice that my query only receives the data it needs for the app to display, such as the name, the image associated with the data, the ID of the restaurant. We don't need, for example, to know when the record was created or when it was last updated in this case. We just want the basic information about the restaurant that would be useful to the user. Let's look at this exact GraphQL query used in the code. So if I find my restaurant list component here, you'll see this is the query that we actually just saw in Strapi. Because, as I mentioned, it's only pulling the information it needs, like the name, the description, the image, that minimizes the amount of data that is transacted between the front end and the back end and helps the app to run more efficiently. So now that I have declared this query here in my code, I actually end up executing it over here. And in the data, if the execution hadn't succeeded and returned data, then I might see an error, which lets the user know there was an error loading the restaurants, or if the data is taking a while to return, then I have a loader component that kind of shades the app in a layer of green and has a little animated circle to let people know that the app is trying to load. And then if data is successfully returned, I can manipulate the data by accessing, for example, the restaurants field and then the restaurants data field and drill down to what I need, because I have actually had access to see that data object in the GraphQL visual interface, which was really useful. So this concludes my presentation on the database and the API. My third and final video will include a demonstration of the app plus details on the deployment process.